them. Okay. Okay, so now things change. When you sketch a graph and it's a word problem, there's a context around it and it's a word problem, we need to label the axes with words and units. So if it's time along the x-axis, and you also want to make sure to say what units, seconds, days, hours. Okay, so now we're going to not use x and y anymore. We're going to actually label it based on the context. Start just like before. You find the vertex, you find all the intercepts. This will give you a good idea what scale to use when asked to graph. Okay, most of the time, variables need to be positive. I say most of the time. Okay, the variables need to be positive. So the majority of our graphs will be limited to quadrant 1. The majority. I don't say all of them, okay? And I said most. So don't be saying, you always said it's going to be in quadrant 1. It will change down the road, but not right now. You're still learning how to work with these guys, okay? So let's look at this one. Does this look quadratic to you? You should say yes, because you see a squared variable there. The only thing is, do you have x and y in here? No. But the thing remains, anything that's on the right-hand side is your x variable, and this is your y variable. So I can tell you that this is your y, okay? And this right here is x squared, and this right here is x, okay? So nothing changes. It's still a quadratic. But every time you are given one that has letters other than x and y, or a formula in general, an equation in general, will tell you what it represents. Okay? So in this case, I tell you that h of t represents the height in feet, and t represents the time in seconds. How's that important? Well, now every number, every coordinate on that line is going to talk about time and height. How do I know time is my x variable? Because t is on the right-hand side, correct? And that is my x variable. So I just go find out what is t. It's time. Well, that's where time goes on the x, and height goes on my y. So every single point is going to tell us that at a certain time you are at a certain height. Okay? So let's say you throw something. You throw a ball, and it kind of looks like this. So if you're in physics, you're going to have seen some of this already, projectile motion, right? We can tell exactly how high the ball will be at a specific time. Okay, so the calculator will allow us to use that. We had a specific name for these ones. This would be our y-intercept. This would be our vertex. And this is our x-intercept, correct? All right. So how do you write the y-intercept normally? It will be the x value will be 0. And you'll have a number here, correct? 0 is also a number, I know. But you know what I mean? It's going to be other than 0 most likely. The vertex is just going to be x and y. We're going to leave that. And the x-intercept is going to be what? A number, but then y is equal to 0. This point right now, from now on in, we're going to refer to it as the initial height. In this case, it would be the initial height, like where was the ball at the very beginning. So oftentimes, this is called the initial height, which you should know. Oh, you're saying y-intercept. Yes, that's what we're saying. Okay, initial height. The vertex, what does that give us? It gives us the maximum height in this case. And, I should say though, and the time at which that's going to occur. Okay, so it gives us both. If you find the vertex, you're going to know how long will it take to get there, and also what is the greatest height. And In this context, if this is a ball flying, what would we call this? Destination? Is that what you were saying? It would be, you could talk about it as how long did it stay in the air? Like we would find out, right, if X is our time, the ball is flying, and then when it gets to the ground, that's when the action stops, right? Time, object, remains airborne. Okay, so it hits the ground there. And again, this axis here, I'm going to use a pen for that one. I want that to stick out here. This is going to be time in seconds, so you're going to label it like that. And this is going to be height in feet. Mr. Dirksen, does that mean that points in between these important ones are not going to matter? No, they're going to matter, but these are the ones that we're going to use to graph, okay? I'll tell you right off the bat, will the ball always land on the ground, you think? No. It could be sometimes it lands on a roof or on the top of a car, or somebody catches it. So it could be that this ball will go flying, and then it will stop somewhere, right? So don't think it always hits the ground. Is it possible that the ball could start or be right here? Like let's say it's soccer, right? You would kick it, or football. You would kick it like right from the ground up like this. So don't think that this is the only scenario, okay? It can vary. Let's talk about domain and range here. Am I going over here to the negatives? No, because the time cannot be negative, correct? Is this going to go underground? Usually a baseball, if this is a baseball that we're talking about, I'm not sure what we're talking about, but depending on the context, this is where it stops, right? We don't go underground. So don't be extending your lines if it's a word problem. Read and let it tell you where it stops. Where does it start? Where does it stop? Okay. So here's the domain and range. The domain always talks about the x values, right? X values for which the graph exists, and the range is the y values. And there we have set notation and interval notation. So when it's set notation, you would use, in this case, it would go from time of 0. You have to use the variables that the equation is using. You cannot use x. And what would be here? This would be the x value of the x-intercept, correct? That would be our limit here. So we call this the x-intercept. I'm just going to say it x-intercept like that. Set notation for range, in this case, I'm just going to say this. It's the lowest y like this, and then what's our variable here is h, correct? And then this is going to be the y of the vertex. Okay. That's set notation. If you want interval notation, that's much easier. In this case, you would go from 0 to whatever your x-intercept is, and most of the time we're going to use square brackets. It's going to be included. For the range, you would go lowest y and the y of the vertex. I will say this most of the time. So you can't say, you said all the time. Most of the time, this is going to help you out. And we're going to practice that. So let's go to page 33. This is going to give you, probably remind you of last year, and now you know why your teachers kept on talking about domain and range. I hope at least you covered that, because it's coming back in grade 12. So let's say, I want you to state the domain and range for all of these here. Okay. I'm going to do one with you. I'm going to use two different colors. I will use pink and green. Okay. So I'm going to use pink for my domain and green for my range. You pick any two colors that you'd like. So what are we talking about here? We're talking about length, the length of something, and the resulting area. So we're comparing length and area. You know this is a word problem now, right? So as you make the length of a box longer and longer, the area keeps on going up, going up, going up, and there's a point where you reach the maximum area, and then as you extend the length, it gets actually short, like the volume, the area decreases. Okay, that's what's happening here. It doesn't really matter all that much. All that we care about is our domain tells us the x values that are acceptable. And this is telling us that it starts at 0, right? If we travel along the x-axis, we see the graph, right? We see it, then it stops right here. And the x value at this point is 450. So my domain goes from 0 to 450. I like interval notation, but I need to teach you both because sometimes we give you a multiple choice question. I'm like, which one is the domain for this scenario? You got to be able to see the set notation and tell, okay, this is the one. But I use this one most of the time when I have to answer. Okay. What is my range? My range in this case goes from here, and it keeps going until you reach the top of this hill, right? That is like the highest you can go for y. So it starts at y0 here, and it goes all the way up here to which value are we going to use? We're focusing on the 50,000, right? So this is 50,000 right here. So my range is going to be from 0 to 50,000. Yeah, the values are dependent on the context. Okay? Always lowest first, greatest second, okay? Always lowest, largest, always. Don't mix that up because then you lose, like it's actually a -1. What if you do set notation? You want to translate both of these to set notation. Well, I'm telling you this. You're going to have the limits. I call these limits sometimes. You're going to have them on either end. All you have to do is that saying that the variable is wedged in between these two. So in this case, I'm going to use L for length. Okay. So if you don't know what that, right, length is right here. And same with the area, this here, I'm going to use the letter capital A. Does it matter if you go lowercase a? Not really. And it's going to be 50,000 on this end. So you're saying A is greater than 0, but it's less than 50,000, right? So you're kind of like putting a fence around it. It's like, hey, this is the only ones that apply. The only ones that apply for A is anything between 0 and 50,000. Beyond 50,000, it doesn't exist. In the negatives, it doesn't exist. Okay. So, where are we at? We have a bit of time here. I want you to, for now, just focus on interval notation for both. Let me see here. I'll do one more. Let's do, I'm going to skip this one. Let's go to this one. The ones I don't do, they're on, I want you to do them as well over the weekend. Okay, so doing a little bit of domain and range refresher there. So for this particular scenario, we've got height What are we comparing? Height and time in seconds. Can you imagine a scenario where you would have something like this? If this is height, you are now below the surface of the water perhaps, or below underground, and something is, right, something is going from underwater or underground, it's going up, and it gets airborne and it lands. So I was thinking a submarine, shooting a missile or something, and then it goes right from underwater up, reaches the highest point, and then its target. So for the domain, we would go like this, right? We would go from here all the way to there. So what would be the limits for my domain? 0 to 10, yeah. And my range, I go from here, this is the lowest it ever gets, travel along the y-axis until you get to the highest this thing ever gets, which is right there. So we know it goes from -20 all the way to +3, correct? So you got to make sure you grab the lowest first and then the highest second. So that's how you would state the domain and range for this particular situation. Translate it. Translate it. Set notation. This would be 0, right? And what letter should we use? I'm going to use T for time. So use something other than X and Y. Go by what the label is. And then it goes to 10. Okay? So once you know the interval, it's actually not that hard to translate this one from -20. And I will use H for height all the way to 3. Okay? And that's how you do domain and range. So basically, I want you to do this one for homework. It shouldn't take you that long, right? Like minutes, we're talking minutes here. And homework there. As well as the one that's on 34. There's another one there. What's going on there? Which one is this one facing? Which way is this one facing? Up, right? What is A going to be on this one? Positive, right? The leading coefficient is going to be positive. So I want you to also state the domain and range for that one. They all have a bit of a, like you got to think, right? What's happening here? And I'll post a key to this as well. I'll stop there. How's that? I wanted to go a little further, but that's it. That's all. One thing. I'm just going to cover this so I don't have to do this on Monday. This part right here. This is just for your information. Make sure you write this down. It's actually very simple. If you're giving a quadratic form in general form, we're going to focus in on this. If b is equal to 0, in other words, x is missing. Not x squared, but just the x term is missing. I'll give you an example. Let's say you have h of t is -3x squared plus 5. Can you see that x is missing there? Right? It's very obvious. Then the vertex is equal to the y-intercept. That's a pretty cool thing. Okay. So what am I saying with that? That you know where it hits the y-axis here? That is actually the vertex as well. That's the highest point. So this is when you imagine something being rolled off a cliff, right? Or when you watch cartoons, right? Off the cliff and then they fall down like this. So they're not jumping up. Like this isn't a story where it first goes up and then down. It goes straight down from the highest point. Okay? And then if b is not equal to 0, okay, then it's just that the vertex is not equal to the y-intercept. Okay, so that the y-intercept is here, and the vertex is up there. So there is a higher point. It goes up slightly. I need you to know that because sometimes students are confused about it because they find the y-intercept. They're like, how come Mr. Dirksen, the y-intercept is the same as the vertex? Don't be alarmed by it. It could happen. Okay, so vertex is the y-intercept. That's all I wanted to throw in there. And you might forget about it, but then later on, right, at least you've heard me say this